This is using certificates on macOS 7. That's what the sign said outside. So, unfortunately, I prepared this for something a little bit more modern. So hopefully it'll backport to macOS 7. I'm Tim Perfitt from Twoact Software. We do a lot of dual boot cloning software. We also have a product for getting certificates for Active Directory, but this is not really focused on that. I'm not going to be talking about our products. It's going to be talking about using certificates on macOS to access services, mainly to Active Directory, but it can apply to other environments as well. So before I get started, let me talk a little bit about the setup I have here. If people know me, I usually like kind of convoluted setups that tend to have a lot of wires that stick out of them and are overly complicated but are fun to look at. So what we have here is I have a Mac Mini that's running VMware and Windows 2016 server. It's going to be my certificate authority, and also it's going to be a Radius server, which now I have an access point, and we have two SSIDs that you'll see. There's an SSID that's called PSNet, and there's another one called Secure. So if you want to connect up to them, last I looked, they're virus free. They don't really have a lot of content behind them. But you'll notice if you connect up to PSNet, you'll be prompted for password. If you connect up to Secure, you're going to require a certificate. So that goes into the motivation. So how many people are here because they're fighting with 802.1x? Okay, a lot of people. So that was the big motivation for me, is that a lot of enterprise environments use 802.1x to be able to get onto the Wi-Fi network. And this is a very common way for PCs to join it. It doesn't necessarily use passwords. It uses either certificates as a second factor or the primary factor. But what's nice about it is if you just open it up and join that work, you don't really have to do any interaction, but it's a very secure system. But there's some trouble with getting Macs onto that network. And if anybody's opened up and look at the profiles for wireless configuration, there is 10,000 different options and checkboxes that you can check, right? And so setting it up in a lab is difficult to do because it's not realistic and you don't really want to use it in a day-to-day kind of a personal way. But that being said, my home network now is secured by EAP TLS and certificates, which is pretty much the only house in my block that does that, which is pretty cool. And hopefully you, at the end of this, will be able to do the same crazy things and have your family mad at you as well for making their wireless setup overly complicated. But what's cool is that you'll be able to, if you get it right, it'll be more seamless for you. And if you ever get a divorce, your kids leave the house, you can then revoke the certificate and they won't be able to get on your Wi-Fi anymore. So what I plan to do in this session, so it's, I don't know where I place this, if it's basic or advanced, but what we're going to do is we're going to start off with some analogies, some very simple stuff. There was a session earlier that talked about certificates. That was a great session, dive in, talked about specifics on certificates. What we're going to talk more is about how to use them. But before I do that, I'm going to go through multiple times kind of what these keys are, to have a good concept of what symmetric and asymmetric keys are, and how do you use them kind of in, not even the real world, in an analogy world, right? So I'm not going to talk about like the attributes on a certificate. We'll get into that a little bit, but what I want to do is just kind of have a good conceptual idea of how you'd use not just certificates, but these keys. So I love to use these old-timey keys. So a symmetric key, a wonderful thing with a symmetric key is it's symmetric. It goes both ways, right? You can, if you lock something with it, you can then unlock it with it, right? So it's very much like a bicycle lock or something like that. You have a symmetric key, you put it in, you lock it, you put it in again, you unlock it. It's like every lock we've ever used, right? And there's some really nice advantages to this. So you put it in the lock, you lock it, you unlock it. So that's a very simple, conceptually very simple thing to do. And what you would do with this is you would just distribute those, right? So you would take, you'd make up a password, you would secure something with it, and then you would just share it to everybody else. And then if somebody in your circle of trust is no longer in your circle of trust, you have to no longer use that password, and now you have to give new passwords out to everybody else, right? So this is a great way to work if you have a small number of people. And so does this sound familiar, right? So this is when I go to every hotel I check in, they're like, do you want to use Wi-Fi? I'm like, yes, I do want to use Wi-Fi. So they hand you a little card, and it has the password of Josh Eats Worms. That's weird. Every time I see that. It is universal truth. And so Wi-Fi, very common to have this shared password. This was the way my Wi-Fi network at home was set up before, right? Before I got a hold of it. So you just have this password and you share it out and give it out to everybody. Which for me personally now means that every one of my son's friends now knows what our Wi-Fi password is, right? So I don't know really necessarily who can join my network and who doesn't. So it's a very common way for just ad hoc networking. So there has to be a better way. So let's talk about asymmetric keys. So asymmetric keys have some really interesting properties. So it means that it's not like you have a key, it'll do like symmetric keys. It splits the functions of a symmetric key. When one key locks it, the other key can unlock it, right? Which seems like a very simple concept, but it gets really complicated very quickly. So what I'm going to do is show an example of that. So the kind of the circle is whichever key you use, well, you can't unlock it with that key. So if I take one key, lock it, I can't put that key back in and unlock it. Right, which seems to me kind of crazy, right? If I send an encrypted message, I can't decrypt that message. So I can do something that I can't undo. So there's some rules to this game. And I want to play fast and loose with this right now, okay? So if you know a little bit about cryptography, pretend that I know what I'm talking about, and I'll get to the specifics later. But this is kind of big brush kind of stuff. So when the first rule of this game is when one key locks it, the other unlocks it. And a key cannot unlock what it's locked. And the other thing is that each key can lock or unlock, right? So it's you have this key that functions as a key, but only can do one operation, and the other operation can undo it. So let's do a metaphorical example. It's a two-act play. So what I have here is an encrypted store, which is an envelope. And I've got a couple of, I've generated my asymmetric keys. So I have what's called a private key and a public key. Let's not worry about the terminology for right now. So for the public key, I can't believe I just showed you my private key, but pretend you didn't see that. So my public key, I'm going to post this up to the world to see. So here's my public key. So everybody can see that. So that's one of the keys. I generate two keys that are these key pairs. So I'm going to share out my public key. I'm not going to give everyone public keys. But you didn't know, but the Penn Stater is actually asymmetric keys. No, I'm just kidding. They were nice enough to give me these at the front desk. So Sam here says that he would help me out with this. So I'm going to share my public key with Sam. Not because I trust Sam, but because it's a public key. In fact, don't ever trust Sam. Where'd Josh go? Hi, Josh. Josh is now I'm going to share my public key with Josh. Sit on the end, Josh. Thank you. And I'm doing this specifically spatially. So Sam is kind of in the middle. So every message, this is an unsecure network, right? And this network includes Sam, and Sam is going to try and read messages that are not for Sam. Okay, so I'm going to try and communicate with Josh, and let's see how far we can get. So I gave everyone a pen that have these, and you can write a message. So I have two keys, my private key and my public key here. And so what I want to do, the first thing I want to do is I want to get a message. I want to get a message from Josh. So following our rules of our game. So Josh, think of a number between 1 and 10 trillion. Okay, and write on that piece of paper and put it in the envelope. Please don't seal it. We'll pretend that it's locked, because then always we can't use the envelope. Okay, and then hold it up and wave the public key over it that will lock it. Go. All right. Okay, so it's now locked with my public key. All right, now you want to send it to me, but unfortunately the only route in your routing table is through Sam. Yeah, I know. It's not the most efficient routing table. So if you can pass it to Sam, actually Sam, if you can meet Josh in the middle, it's I don't know what that, an ad hoc network, the analogy's breaking down already. It's airdropping, yes, he's airdropped it. Now Sam, wave your key over that. What happens? Nothing, because the rules of the game is a public key the same key can't lock and unlock something, right? So I'll take this, now pass it to me, and see, this is in the public, so each one of you saw this. And you waved it, and you're like, ha, I'm going to find out what number Josh did. And you find you can't. So then I wave my private key, and what happens? I can go in, I can see. What do you think he did? 42. Very nice. Very nice reference. You could have gone a different direction with that. I appreciate that, Josh. I appreciate that. Okay, so that's great. So, but this key, so that was my public key. So let's turn around. Let's see. I said to you, one of the rules of the game is I can lock something. So I'm going to write a number and put it in with my locking one. And I'm going to put it inside this lockbox. I'm going to wave it. So I take my private key. I wave it on here and I lock it. So the rules of the game, can I see what's in there? I threw away my number. I forgot it. Can I get back in here? No, I can't, right? Which is an interesting artifact if you ever tried to get into old S-MIME messages. You can't read messages you sent if you don't have the keys anymore, which is a wonderful tech support call to get. So I give this to Sam, because every message goes through Sam. Sam's going to wave his key, and what happens? You don't, but I lock, oh, I'm sorry. No, that's right. No, I have my private key. I locked it with my private key. He doesn't have a private key. No, you can open it up. You have a public key, right?
I can't.
Well, yeah, you can. I locked it with my private key. The opposite one can unlock it.
Oh, yes.
That's right. You think, yep. Ooh. So you can see it. Bear with me. This was an analogy, people. Now pass it over to Josh. No. It's a message. You looked at it, and then you made a copy of it and looked at it. Now take the original. See, this is where the analogy in the real world breaks down a little bit. We don't have infinite copies of things. All right, so I locked that with I encrypted that with my private key. Now, Josh, can you see what's in there? Yeah, in my example, I can, right? So what did that do? Absolutely nothing, right? I encrypted something that everyone can see. So that means, why would you ever do that, right? But who can't see what's in there? Well, I can't see it, but I have my public key as well, right? So the very act of opening it up with the public key tells you what? That I encrypted it with my private key, right? So it's a very simplified idea of what I did is I signed that message. They know that I have the private key because they had to use the public key to unlock it. Okay, so that's the idea is that you have these two keys. They both can encrypt, they both can decrypt, but there's two ways to do things. One is encrypting it, which means that somebody else takes my public key and sends it to me. The other one is signing it, which is I take my private key and I send it out to the world. It doesn't work that way in real life, but it's a good analogy. I'll talk about why it doesn't. So let's talk about what we did. So, before we did that, thank you for participating. You get Starbucks cards. There you go. This is only so I get good ratings from these two people on my.
Are they locked with your keys?
Yeah, they are locked my keys. I signed them, so they're valid. Actually, I've used them both already. They're actually used cards. All right. So now we have an interesting thing. So I can generate these two keys, and I can share one far and wide, right? So I share this out, and then I can use it. The first one to do is you can encrypt the document, which means that Josh can encrypt something that only I can see. But what's really weird, right? This is where it kind of like, I always have to think about this, and this is why I want to review it, is because if I want to encrypt something and send it to Josh, I've got these two keys. Which key do I use?
His public key.
Right, I can't use either one of my keys to send anything to Josh, which is crazy, right? Because that's always like it's a mind bender. I have to get Josh's public key to send something to him. Right? So you got to view these operations as when you're signing something, you use your private key. When you're encrypting something, you use somebody else's public key. So there's two kind of symmetric operations. And this is kind of where the analogy breaks down. So there's two rules we kind of played fast and loose with. You can't really encrypt, well, Josh only did, by the way, my number was 142, if anybody wants to know. Josh did 42. I just was 100 more than Josh. That's all that was important. So you can only, these two keys, let me get back to my keys. These two keys can only encrypt small amounts of data, and it's based on the key size and the mechanism that you use, but let's just say a small amount of data, right? So you can't really encrypt anything worthwhile with these keys, right? You can only do a little blob of data. So we couldn't really encrypt random messages inside these envelopes. And the second analogy breakdown is that decrypting doesn't mean the data has not been changed. So the example of taking the act of decrypting something with the public key, and I said that means it was sent from me, that's actually not true. It's close. Because if you change, because it's a mathematical formula, if you like multiply everything times 100, it doesn't matter if you put good data or bad data in, it's still going to be times 100 when you come out. So we need another way to actually know that it's actually the message that we're sending. So the way we solve this is through two techniques. One is called hashes, and the other one is called symmetric keys, right? So we talked about symmetric keys before, and this is kind of the one kind of fun thing to say is you use asymmetric or symmetric. If you say asymmetric, we're using two keys, it pretty much always means you're using symmetric as well, right? So it uses both those technologies. When you sign something, you're usually just sending a hash, and we'll talk about that in a second. So let's go through a complicated example. This is where it starts getting kind of deep. So I want to do that same exercise where I want to encrypt something, right? So Josh wants to send me a message, right? He takes my public key, and he can't encrypt that message because it's too big. Josh talks a lot. He's a little bit verbose. He didn't have enough time, so he didn't write me a shorter letter. He has a lot of data. But what can encrypt large amounts of data? Symmetric keys. That's what we talked about before. So he does a two-step, right? He says, okay, what I'm going to do is I'm going to take this document, and I'm going to encrypt it. I'm going to come up with a password. And I'm going to encrypt the document with that password, and then I'm going to take Tim's public key, and I'm going to encrypt the symmetric key with it. And then he's going to give that information out. And so when I get it, what do? I can't look at the document. I take this document, I'm like, this is encrypted data. I can't do anything with it. But then he gives me a little blob that says, use your private key to unwrap the symmetric key. Right? So it's kind of what they say, there's no problem in computer science that can't be solved with another layer of indirection, right? So, or two. So Josh takes the symmetric, he comes up with a password. I know for a fact that for everything, password 123 is what he uses. He does that, he encrypts, yeah, sorry about that, you have to change it. I also know that he always just adds another number on the end, so. You take password 123, he encrypts it with he encrypts the document, he encrypts his password with my public key, gives it to me, I get the password out, then I decrypt the document, right? Make sense? All right, the second mechanism is when I'm doing this signing. So I was doing the other way, right? So I have my private key, and I want to send a signed message to Sam and to the world, right, to prove that it's me that wrote it. So what I do is I use what's called a hashing mechanism. And a hashing mechanism just takes a large amount of data, and it runs a checksum over, something like a checksum over it, and comes out with a fixed numerical value. And if the document changes, the numerical value changes. And what's the nice thing about taking a huge amount of data and bringing it down to a small amount of data? I can now use these keys to encrypt it. Because before, I couldn't encrypt a big document, but I take a hash, and this checksum will tell me if it's been changed. So I write this great the novel of my lifetime, and I want to make sure it comes from me, that it wasn't stolen by Sam to put his name on it and post it up. So I want to sign it. So I take my private key. I take my private key. I run a hash of the document, and I encrypt that hash with my private key. So now I send it to Josh. And what does Josh do? Josh, what do you do? Yep. And how do you validate the hash? Do you know how to do that? Well, you have the original document, right? You can run a hash of it. So you have number 1. Let's say it's 42. And then you decrypt the hash that I sent you, and what should it be? 42. And if they're the same, it means the document hasn't changed. All right. Everyone clear, 100% would be able to get all that? Conceptually, it's important, and we're going to get into like the whole how to use this stuff in a minute, but I want to go back through that one more time. Do we want me to go back through it? Raise your hand if you want me to go back through it again, or just move on. Well, who wants me to go back through it again? One person. A bunch of people. Okay. when somebody asks me, like, when I'm explaining something and I say, when I'm signing something, I use my, and there's always like a 3-second pause, right? I think I use my public, private, somebody else's public key, right? Because this stuff is complicated because it's not, that if I'm encrypting something, why the hell would I use a public key, right? That seems counterintuitive. So this for me is conceptually difficult because the terminology doesn't necessarily line up with what real life, what you're doing. So again, if I want to encrypt something, if I want to have an encrypted message, so let's turn this around to get an example if I want to send something to Josh. So I get Josh's public key, and I want to send him an encrypted message because we have some secret plans. Most of them involve Joel. And we're going to, I want to encrypt this message, right? So it involves handcuffs and vodka. So anyways, so we take, so I take that document and I encrypt it with a symmetric key. I come up with a password, AFP548, right? And I encrypt this document with that password, AFP548. And I take that, and if I gave that to Josh, Josh wouldn't know what that symmetric key is, right? He doesn't know that it's AFP548. He sits there and he's running rainbow tables on it, trying to hack it, can't figure it out. So now I need to send him that key, that symmetric key. And the best way to do it is I encrypt it with my private key, and I give it to him. And then, oh, no, I'm sorry, I encrypt it. See, I did it right there. It's conceptually difficult. I encrypt it with Josh's public key, right? So only Josh can read it because he has the private key. And then he takes that symmetric key out, decrypts the document. We kidnap Joel, leave him naked in Las Vegas.
Or just another weekend.
Another weekend, yes. All right, so now, then I get a message back, and Josh says the plans are off. But I don't know if it really is from Josh. So I want to find out. What's that? It could be from my wife, right? So I want to figure out, is this message signed by Josh, right? So what Josh did is before he sent me the message, he ran a hash of it. His favorite hashing algorithm is MD5, of course. Just kidding. Anyways, so he takes an MD5 hash of it, which is a hashing algorithm, gives us a checksum. Then he encrypts that with his private key. Then when I get it, I can use his public key and see, no, it's not from my wife. It's actually from Josh. We call the plans off, and Joel is safe. For now, yes. Well, I'm getting the message from Josh, right? So he encrypts the hash with his private key, and then I use his public key to decrypt it. And then I run a hash of the document and match the two hashes. Yes. Difference between signing and encrypting. But there's always encryption and decryption. Signing is just a way of looking at it differently from the keys perspectives. All right, so now we want to look at Wi-Fi. So it's gotten more complicated, but actually it's more fun because this is the kind of systems I like, right? Ones that involve lots of keys that are complicated and a cradle point router. So now I have all these users, instead of having this shared password, they've generated their own key pairs, right? They got their hotel room keys. And they go over and they give me their public keys, right, into this Wi-Fi network. And now when I want to be able to authenticate them, it's easy, or it's not easy, I can now do it individually, right? I can now I can have them prove to me they have their private key. And that's really what it comes down to, is when you have key pairs, is having somebody prove to you they have the private key, because that shows that they are who they are. And the cool thing is, what doesn't happen here is if I want Josh to prove to me that he has a private key, I'm going to say, Josh, send me your private key. No, that wouldn't do it. Josh is not going to do that, right? Because he keeps a private key private. He always keeps it. So what he wants to do is do a challenge. And I have to verify that he has a private key. And the way I do that is by using his public key to verify it. So that means that when we go to this Wi-Fi network, it means who never has the passwords, right? What happens if Sam comes in, he takes his Pixel book, he hacks in to the Wi-Fi, and he steals all the passwords. What does he get? What's on the Wi-Fi network? What keys did I collect up? Public keys, right? And then he goes back, he's like, curses! Because all he can do is just verify these people are authenticating. Right? He doesn't have access to their private keys, which is one of the big reasons. If these were all symmetric keys, what would Sam have access to? Everybody, right? And if you use people's Facebook passwords or their Gmail passwords for your Wi-Fi, you would have access to their other systems as well, right? So the idea is it never exposes your private key. All right, so let's just look at one specific example. So we have this person. I was going to change this as a placeholder, but I got so used to it. The guy with the cane, I thought that was great. The old-timey keys. When you want to connect up to this Wi-Fi system, you say, I want to connect up to this Cradle point, so here's my public key. But the one thing that doesn't do is say, I don't know who you are, right? I know you have a key pair, right? But are you Tim Perfitt? Are you Josh? Are you Sam? I don't know who you are. So just having a key doesn't mean that you are, I want to allow you into my system, right? I want to trust you, right? I need to have somebody that tells me who's trusted. So now this is where it gets really freaking complicated. You have another person, you have an authority with a key pair as well. And what they can do, they have keys, they can do two things. They can sign and they can encrypt. And signing will prove that they issued that document, right? So that proves they have the private key for that organization. So what I want to do is have somebody with key pairs, somebody like VeriSign or Komodo, or even your own certificate authority that you've trusted, to say, vouch for people, and say, I vouch for them. So let's talk about how they do that. So don't think of it as being the certificate authority as this large corporation that has lots of data centers, right? It could be somebody else with a key pair, right? And they're sitting up there with the, what's the I for? The Illuminati, right? So the Illuminati, which controls everything, controls certificates as well. So the Illuminati have created key pairs, and anybody the Illuminati trusts, we all should trust, right? Because they control everything. So any certificates and anybody they vouch for would be good. So the person that wants to connect up to the Wi-Fi, they send their public key, because they share that far and wide. They share their public key up and give that to the certificate authority. And the certificate authority creates a document, right? And that document that says this person's public key is trusted by me, right? I vouch for this person. And I might put some other identifiers like their email address, what the keys are used for, how it's encrypted, but it doesn't really matter, just what's a document. But how do I create a document and show that I don't want somebody else to spoof that? So they take their private key, right? Then they run a hash of that document, they encrypt that hash. And anybody that has the public key for that certificate authority can now verify that was signed by the Illuminati. All right, so now we go back to this example. We have Josh, or whoever, wants to authenticate to the Wi-Fi. And instead of saying, okay, here's a random person that wants to join the Wi-Fi, you say, here's my certificate. And I look at the certificate and I can tell it's been issued by the Illuminati, it has their public key in it, and it's trusted, right? And so then I can allow them that person has been basically delegated authority, or I know who that person is. All right, so that's the primer for what we're actually going to do. And this is when I told myself I should not do this as a demo because there's way too many people, can have too many problems, but I don't care. Let's just do this. So I have a Cradle Point router up here. According to the specs, it can handle 64 connections. And I would like people, if they want to join in and do this one as well, so you can generate your own certificates on your Macs from a certificate authority on my little Mac Mini up here. All right, so let's go in. First thing you do is go into certificate keychain access. Wow, that's really small. Okay. What's that? Not much better? That's all right. I'm not really going to care about that. So everyone launch keychain access? Follow along. It's worth it. I trust you, or you got to trust me. So go up to Certificate Assistant. Go to Certificate Assistant and Keychain Access and do request a certificate from a certificate authority. Okay? So what does this do? So from what you said at the first part of it, when you want to do, remember the person would have keys and they would submit it. So what this does is once we hit continue, it's going to generate a public and a private key, and then it's going to make what's called a certificate signing request, which contains what? What do you think it contains? Does it contain the private key? No, because you don't ever share your private key. What are you going to send up to the certificate authority? Your public key, right? And maybe some other information. Turns out the other information it can use or it can't use, it's up to them. So go ahead, and one of the nice things about Certificate Assistant is that you don't have to mess around with all the complicated stuff with choosing your mechanisms or even worry about the email address. So just go ahead and click Save to Disk and hit Continue. And then save it to the desktop, because who doesn't want a cluttered desktop? Nope, you don't have to enter anything. If there's no email populated, you have to put something in there, because my certificate authority is going to ignore all your data anyways. Did that work? Everyone has certificate signing requests on their desktop. Click on Show in Finder. And now I have this certificate request dot cert signing request. And I open this up in a text editor document, of which Coda is the best. And you can see this is a base 64 blob. And you're saying to yourself, but Tim, what happens if I decode that and run it through an ASN1 parser? Yes, you would get this. Much clearer, right? So if you run this command, I'll post this command. It's an OpenSSL command. What it does, it's because the certificate of signing request is a packed binary document, it will put all the information in. But what I want to do is talk about 3 sections here. So the first one, you can see, I'm reading this. I'm not using my keys. This is all in the clear, right? This certificate signing request is considered, you shouldn't be able to read it, right? Or anyone should be able to read it. So you look at the top section, it has my email that I put in there. That's just referential to help look up to see what account this person may be used to. It's a nice, like a requested identifiers to use. Then in the middle, there's 2 other sections. You see the middle, it says RSA encryption, and the bottom says SHA-256 with RSA encryption. So RSA encryption, that is my public key. So that blob right there is my public key. It was generated when I generated my key pairs. The bottom section is now SHA-256 with RSA encryption. And knowing what we talked about before, let's see if we can figure out what that is. Does anybody know what SHA-256 is? What's that? It's a hashing algorithm. Right, so it means that this has been hashed. And what is RSA encryption? Anybody know? Josh? Oh, well, I mean just generally, is it asymmetric or is it symmetric? It's asymmetric, so this is a hash with some asymmetric. What is it? What do you think this document's trying to do? When do we use hashing? Signing, right? So this document is signed. So I take my public key, I put some other attributes with it, and I sign the document using my private key. That way the certificate authority can verify that I actually have the private key. Isn't that kind of neat? All right, now comes the interesting part. So now go up to your Wi-Fi and choose PSNet. If there's smoke starts appearing on my router, I'll let you know. And the username is, the password. The symmetric password for this, which is what we want to get away from, is proximity ! Or as the cool kids call it, bang. My wife uses that now. It tickles me every time she says it. I'm like, oh, what's the password to Netflix? She's like, 1, 2, 3, bang. I'm like, oh, it makes me so excited. All right, anybody connect? Did it work? What's that? It's trying, okay. Struggling? I spent over $200 on this router, so it better work. Yeah? And when somebody gets on, let me know. At least one person works. You're on, okay. So now connect up to 192.168.0.50/cert-srv. This is the Microsoft Web CA. And you'll be wowed by the HTML you get back. And raise your hand when you actually connect up, so I know somebody's got this working. Access denied. It's best if you use Netscape Navigator. What's that? Internet Explorer for Mac, that's right. Those were the days.
Yeah, you have to do HTTPS for a certain server.
What's that?
HTTPS for a certain server.
Oh, right, you got to do HTTPS first, yes. Bye, Joel. All right. Cert SRV. Let me go back. There we go. Oh, I didn't actually put HTTPS there, right? So I gave you bad instructions. Is that what Josh was saying? All right. Who got in? Did people get that? Prompted? Okay. Now it's sign in as, and this would be where you normally use your Active Directory individual passwords, but we'll pretend that we're using individual passwords, but right now we'll just use PSU01 and PSU01 for the username and password. I always recommend using the username and the password to be the same because it's easy to remember. Not true. Not true. Only in demos. Only in demos.
I like how the first login, you're getting enter your username 3 times.
Oh, you do? Okay, that's good. Yes, it's Mavis for security. It helps with the typing. You don't forget it. All right, people got in? All right, so now the next step is you want to open up that certificates. Oh, no, sorry. The first thing you want to do is do an advanced request. So there's on the browser, it'll say, do you want to submit a request? Hit advanced, and then open up your certificate signer test and paste it in there, and then hit submit. And I'll actually do that with you. PSU01, PSU01. Yeah, the password on this router, Josh, is password 123. Just kidding. Okay, here we go. PSU01, PSU01. Oh, that is weird. Here we go. Okay, and go to, do request a certificate, and then, wow, this is slow. Can I blame AT&T for this? No, just do, yeah. So do request a certificate. There we go. You don't have to just say advanced certificate request. Leave the default. This is base 64. Either way works, because if I just paste it in, it seems to work for me every time. Here we go. And then submit.
So this is what we should replace our Mac servers with?
No, this is like a generic submitting. So the request is, is this how you'd want your users to go through this pane every time you want to keep key pairs? No, this is the pane we like, so that we can make it easy for the users. So once you do that, anybody get to the page where you can download your certificates? Good. So there's 2 certificates you need to download. One's the certificate chain, the other one's your actual certificate. And what's that certificate contains a signed version of your public key. Where is your private key? Anybody have an idea where your private key might be? On your computer, that's true. But you want to keep it secure. Where do you keep all things that are secure on your computer? Keychain. Maybe the secure enclave someday. Oh, I see. This is DER base 64. Is this what somebody was asking which one to use? I think both will work, but anyways. So let me download my certificate. And now if you double click on it, it'll open it up in Keychain Access and say, where do you want to put it? And we'll just put it into our login keychain. And then I'll search on PSU. And you can see, if you select on My Certificates in the left-hand column, you'll have both a certificate and a private key. Unfortunately, I have to charge you $29.95 now every year to renew this, so you can leave the money on your way out. So this is painful, right? This is freaking painful. But once we have these keys, these are the keys to the kingdom. Everything becomes really easy at this point. Well, easy-ish. If you double click on, I have 3, this is going to be doing demo, but if you look, when you click on your certificate, you'll notice that you say this, it says this certificate is not valid, right? It should say that it doesn't have the Illuminati, it doesn't have the certificate authority to trust it. So if you go back to your web browser and you download the certificate chain, and then you drag that file into your system keychain, it'll then trust any certificates issued by that certificate authority. I don't need to do, I mean, you can just take this, drag it over to system, and it'll prompt me to use my voice as my password. And now you can see that the certificate should be trusted. You should have a little green checkbox. Anybody get that far? Raise your hand. Josh did, okay. Anybody else? Did I lose people? Should I go through it again? We good? What do I do? Where are we stuck?
Can I ask you a question?
Yes.
When you create the CSR,
Yep.
does that contain the private key?
It doesn't. The keychain does.
It goes direct to the keychain. Where is it in the keychain?
To find your private key,
Before I import the signed one.
you got to search for the email because it puts it in there. If you do all items, and you just search for the email, because that's one of the things is like how you don't know what it is, and so usually it uses by the certificate signing request. It'll put that identifier in it. So mine uses that email. Yes, you have to. Oh, when you open it up, you said? Yeah. If you add it to your login keychain, you have to explicitly trust. If you add it to your system keychain, it'll just trust it for everybody. Is that not right? Oh, you do have to set your trust level? What do I know? You're not using Safari? Oh, okay. So this is one thing that's kind of for me, as there was a wise old soul by the name of Sean Geddes that told me he used to, or he does, he's in CoreOS now at Apple, but he used to do security on the team when I was at Apple. And he pointed out to me that in Keychain Access where it says My Certificates, it's better to think of that as identities, right? Because My Certificates to me means certificates are really not your private key, right? It's just the certificate that has your public key in it. So whenever you read My Certificates down there, think identities. I want to see both my private, I want to see my certificate and my private key. So I always select down here My Certificates, and it just filters on everything that has both a certificate and a private key. All right. How many people have certificates in their keychain with their private key? Yay, a lot of people. That was way more successful than I thought it was going to be. I thought it was just going to be me. Okay. Because it's not like in my lab I can invite my 50th closest friends and do it. Is there any questions so far when we do it? So now we have, well, we all have identities, right? This is why identities on macOS or on anything are difficult to generate, because you want to do this dance, you never want to expose your private key. This is what it should look like, PSU01. Normally this would be your individual user account. They would sign in, Active Directory, any other certificate authority would have your name there. And we did the trust on the chain. All right, so now let's use it. Like, okay, I got this power, let's do something with it. So what I did is I went into this as an IIS or web service running on this Mac Mini under Windows Server. And if you go to that same URL but put port 444 after it, it does certificate-based authentication. So if you go to HTTPS 192.168.0.50.444, it won't ask for username and password, it'll ask for your certificate. And almost always on the internet and you get this prompt, you're like, what is going on? I don't know what to do, this is horrible. But this is the time you actually do know what to do, right? Because you have a certificate. And the web server is trying to figure out what? Well, it's trying to figure out what certificate, but it doesn't really care about that. it wants to prove that you have the private key. So you choose the certificate, it sends the certificate to it, it verifies that you're a good user on that system, then it does a challenge and says, let's see if you have the private key. And if all that works, you'll see a picture.
A beautiful picture.
A wonderful picture. Oh, no. No QR codes. 10% off WinClone. No, not going to do that. All right. So is it all, how many people view this as unicorn and rainbows? All right, good. So we got some people in. For those folks that are not following along, this is what it looks like. Now, if we forget the first, 40 minutes of this session, right? And you already had an identity pair, and you went to log into somebody, and into a website, and it didn't prompt you, but it used your public-private key pair of your certificate, that's cool, right? If we can log into all websites like this with your key pairs, that would be great, right? And that's why people want to use certificates to do stuff. Is once you install them, it's really secure and really convenient for the user. In fact, my example is like when people complain about passwords and how passwords are fundamentally broken, you look at systems that do work, right? And one of the things that's really kind of amazing is cell phones, right? Because the way the cell phones authenticates to the cell network is you put a SIM card in it. And you know what a SIM card is? It's a smart card, right? It has a certificate and it has a private key in it. And so when's the last time somebody says, I can't log into my cell network, right? Nobody says that, right? Because you get the SIM. It's the identity's put on your device and you're using that. And they have control over if they can do it. How many times has somebody hacked your device and started using your cell plan, right? It doesn't happen. It's not that common, though. In this group, it might have. But for my mom, it's not happened. She just installs Flash and gets viruses. Okay. Okay. So now, let's talk about Wi-Fi, because I don't expect all you guys to go off and say, I want to do certificate-based authentication to our websites, because the world's not going to do that, because installing certificates is a pain. But there is one environment, 802.1x, where you do want to get your Mac onto these environments. And that's why we came here today, right? So all this talk is talked about getting identity on your devices in an easy way and then using it for these services to be able to connect your Macs to. So let's look at what 802.11x is. So what we want to use 802.1x is to use certificate-based authentication to Wi-Fi. Okay, 802.1x is kind of a framework that does that. But what we're going to talk about is using what's called EAP TLS, which is the most common one, to be able to use certificates to connect up to Wi-Fi. And this is normally run in a Microsoft environment with PCs that have what's called machine certificates. We'll talk about that in a minute. So Windows usually uses remote access services or on a network policy server to be able to say how you authenticate. So it's all kind of Microsoft infrastructure in the back end. If it's not, it's a Radius server that's doing similar things. And remote access services or its ilk can be used, can be configured for certificate-based authentication, but not just that. It can look at the certificate and say only certain kinds of things in the certificate can be used, right? So this is where you get into like, what is the usage of the certificate? That stuff that I said, all those other things like your email, other pieces to it, you can, it can look and see, is that certificate issued, right? Did the Illuminati, the certificate authority, put that stuff in there that's allowed to use the Wi-Fi? So my question to you is, let's say it doesn't work. Can I just go in and change the certificate? Get it to work? Let's say it says it's a user, it says my email is tperfitt and I want it just to be Tim. Could I go in there and just change the certificate and it would work? Why not? I have the data, it's on my disk. It's hashed, right? It's signed. As soon as I change that, that hash will change. When we decrypt the hash, it won't match. And the Wi-Fi system or the Radius server will be like, yeah, I don't think so. Then it won't let you in. So now we get to the wonderful part about users versus computer certificates. How many people have hit this in environments where the Macs use user certificates, but we need to use computer certificates? And that's one of those things that frustrate the crap out of me because it's like, what is A certificate is a certificate, right? What is a user certificate or a computer certificate, right? And so it's nomenclature, and it's how the certificate is associated in Active Directory. And it's ultimately, the problem is the view, the world view, right? So if you have an iPad, most MacAdmins or people with in the Mac IT kind of view it from a user-centric point of view, depending on your environment, right? But administrators that are setting up Wi-Fi or PC administrators, they're looking at devices. They've always managed devices, right? It's kind of separate from the user. It's not a one-to-one correlation. And so that view is really how Wi-Fi networks were set up, is that this device is allowed to get on the Wi-Fi network. It doesn't really matter what user is there. And so when these networks were first set up, they set up the radius server, remote access service, you can see here they went and they selected, it says, when you just submitted that PSU01 certificate request, what the Microsoft Certificate Authority did is it said, thank you for submitting it, you were authenticated, I trust you, I issued it. But it took a copy of your certificate and it put it in Active Directory in the user account. So right now, if I look in the PSU01 user account, I'll see there's 50 certificates issued. Normally there should only be one, right? Every user would have one certificate. But it keeps a copy of it in the user account. And so if you have what's called machine-based authentication in Active Directory or for your Wi-Fi system, what it'll do is it'll take the certificate, it'll say you're fine to use it, it'll authenticate it, and then there's a requirement that Network Policy Server has that it has to be in a machine group. So it'll take the username, the UPN, email, whatever identifier, and look it up in Active Directory, and guess what it'll find? Nothing, right? Because there's no certificate there. So that certificate is not in a machine group. The other thing you can do is you can say it has to be in a user group. So literally you can just change it. It's not even changing the certificate type. So the way Microsoft does it with the Certificate Authority is there's what's called templates. And when you submit it, you may have seen that when you submit it, there's user, I think there's one other one I made available. What it does, it has collections of attributes that it puts in the certificate. So if you say user, it's going to go and get your UPN, your identifier in Active Directory. It's going to go get your email address. It's going to put that in your certificate, which means you can use it for all sorts of user-related things. If you say it's a machine template or a computer template, it'll go and find the UPN, the identifier in Active Directory, but it'll also take the host name that's been assigned and put that in the certificate so it can look it up. So these are not, the certificates are just certificates, right? It's a bunch of information, your public key, and then a signature, right? That's not fundamentally different. It's just, is that information put in Active Directory in the right place, and does it have the right information in it? So the question is, like, if you say we need a computer certificate, what you really mean is that the system has been set up so the certificates are put in the right place. So it's actually just a small settings change to do it, but it kind of has some implications about how they're looking at it. So the question is, do you guys want to get computer certificates so it works with your infrastructure, or do you want to ask the administrator to change it to accept user certificates, right? Problem with computer certificates, anyway, actually, does anybody know what the problem with the Mac for getting computer certificates? There's two big problems.
Well, the machines have to be bound to it.
You got to be bound to Active Directory, right? That's one of the big things. Or you have to, there's some ways around it, but there's a lot of pain involved. And actually, I forget what the second one was. I'll come up to me and say, does anybody know what the second one is? I forgot what it was. Oh, right, so there you go. So the user doesn't know the password for the computer. They usually just know their username, right? So what Josh was just referring to as SCEP, they will proxy the connection. It'll get that certificate, and it won't associate it to the correct place in Active Directory unless you do a lot of back-end scripting kind of stuff. So it's really kind of set up to be associated with the user account. But it doesn't have to be. I mean, literally, this is, let me show you what the setting actually is. Let me go into my network policy server. So there's two sections here. One is who can connect, or what's this apply to? So the conditions are that that's really hard to see. Can I do this? Does that work? Whoa, sweet. So I just have day and time restrictions, and it's a Wi-Fi connection. So that's the only conditions of trying to authenticate. And then once I actually authenticate, you can see under my conditions here. Oh, no, this is actually the one with wireless. This is what the two conditions are. One is that it's got to be over wireless, which makes sense. The second one, it's got to be part of the domain users group. And if I remove this and I say add and choose machine groups, and what's the standard one in Mac? Computer, just computers, I think, isn't it? Come on, somebody tell me, what's the domain computers? There it goes. And then if I remove the domain users, now we have that situation where you guys can't use your certificate, right? Because it's going to go into your computer. If I'm not bound to Active Directory, it won't have a computer account, right? So now it does that. So literally, if you go to your folks and you say, add the user, allow users to authenticate to wireless, then all these certificates will work, right? Which is why you have this like, my gosh, what happened? Josh, do not hack my system. So if you can allow the user to authenticate, then they can go into the Wi-Fi and they don't have a problem. They can generate these certificates and makes it very easy. So when you get to the situation where do we want to use these only computer certificates are allowed, that's really a policy based on who's allowed on the Wi-Fi. And the idea is that can you associate that? So the question is a single change on the radius server worth the pain you're going to do to not have to generate computer certificates? And I'm not saying it's an easy question, right? That person that does it, it might involve committees or a person that refuses to do it, so you have to generate these other type of certificates. But just realize that it's a change. If you get to the right, I always have this philosophy that if you get to the right person, it actually goes like the comment says, like with enough eyeballs, all bugs are shallow, right? If you get to the right person that knows it, they might be able to be fixed right away, right? And that's my time at Apple and working with large companies. A lot of times it's like, no, we can't do that. No, we can't do that. You're the right person. Like, oh yeah, that was trivial. I just made the change right now, right? It depends who the person that understands it and can do it. So just realize that the setting your changes for user versus computer certificate, it might be a trivial change, and it might be a mountain you don't want to climb. All right, so let me show you just a couple other pieces to that. So I showed you the network policies. Ooh, there's my unicorn. Let me remove, I guess I can keep both those in there. Okay, so here's the certificate authority. And here's my issued certificates. And if I go by ID, I can see that 7/12, is that today? It is today. And these are all the certificates that were issued, right? 47 minus 93. 30-some, 20-some. So these are all put in the certificate authority as ones that were issued. And then they're associated into Active Directory as well. And then finally, let me show you the configuration on the router, or on my cradle point, which is kind of interesting. It's interesting not because it's complicated, but how simple it is. Okay, so I have two networks here, two SSIDs. One's called PSNet, the other one's called Secure. If I look at PSNet, you can see it's a WPA password, right? If I unmask the password, I can't do it. That's the one that was proximity exclamation point. So that was just WPA. And then you say, okay, well, the radius stuff's going to be really complicated. It's actually not. If you look at it, it's the WPA enterprise. Zoom in on this. It has the IP address of my radius server and a shared key, right? So this thing, when you buy a router that's 802.1x enabled, the access points actually just proxy the connection over, and they get once the authentication succeeds, it knows that, and is able to do it. All right, any questions on that? Oh wait, do I need the thing to throw around, or up here? I'll do that at the end, I guess. I'll do the throwing in the end. Yes.
That was a Cradle Point. Was there anything special about a Cradle Point?
No, I bought it for something else, and so I could reuse this. Oh no, it was special. I can make multiple SSIDs. I couldn't do that with an airport base station, and Apple doesn't do that anymore. So I figured. I looked for some of the Apple stuff that I did, and I couldn't do 2 SSIDs, and I don't think the one I had actually did radius, but it doesn't really matter. Anyone that'll do radius will be able to do this with relative ease. Other questions? Yeah.
In setting up your home network to do, run into, consumer products like an Xbox or something that got angry about it being more secure, basically, or too secure for it to handle,
Okay, so you want to dive into my home network. This is actually interesting. So I have an airport base station that has, that my son uses, which has a circle with Disney, which is just like it does spoofing, or not spoofing, it's disconnect attacks, or whenever he's connecting a website he shouldn't. And then I have this PSNet one, and then secure that I use for all my devices, kind of thing. Actually, the family I hope they don't watch this video, because the family has no idea these other networks are there. Because if my son knew there was an unmanaged Wi-Fi network, the PSNet, he'd be watching me type the password, right? He's great at figuring that out. All right, let me finish up a few things here. Actually, no, we're not finishing up. This is where we get the real fun stuff. All right, so let's connect to my secure Wi-Fi. So you guys have the certificate now, and you want to be able to connect up to 802.1x. Right? You want to join the fun of the secure network, because it's driving you crazy that there's network you can't connect up to. So I provided a configuration profile, which normally you'd push out. And this is one of the things that really, one of the things about 802.1x, I think it was in 10.12 or 10.13, where you needed a profile to configure 802.1x. Does anybody know when that came about? You used to be able to configure it in the network pane, but now you need a profile. So the profile is this crazy thing where you configure the profile, you have to choose EAP TLS, you have to do WPA2, you have to associate the root certificate with it, and you have to include both your certificate and your private key. And I'm thinking, how am I going to get 50 people in a room to do that, right? So I'm like, easy, I'll write an app. And then I said, hold on, Tim, the answer to every question is not write an app. What I found is if you strip all the crap out of the profile, and all you do is you don't put any of the certificates in it, you can't do this in any of the MDMs, but if you just go in and manually rip all this stuff out, it'll prompt you for all the information. So what I did is I provide, if you go to that one, that certificate, this is so cool, right? Because you're downloading the profile over client-based authentication to get the profile. But if you get this profile and open it up in a text editor, you'll see all it is connect to the secure network using EAP TLS. And as soon as you try and connect, it'll prompt you for a certificate. So try that, connect up, and let me know when somebody gets it. Really? HTTPS 192.168.050.444? Yeah, I got to do the 444s. Anybody get the profile yet? Okay, good. All right, good. So you download it, unzip it, look at it in text editor, because as security folks, you don't want to just randomly install a profile. But you'll see it's just basically just a shadow of a profile. And if you double click on that and install it on your Mac, you'll now be able to connect up to the secure network. And did you notice there's no credentials in it? It's going to get the credentials from your keychain. So you go to, once you get installed, I actually took it off. Install it. Okay, and now if you go into network and your Wi-Fi, you notice there's a new connect button. Right, 802.1x is configured, and if you hit that, you don't have to choose your Wi-Fi network because it's associated with the secure network. It'll choose the secure network, prompt you for your certificate. Right here's my certificate. I choose my PSU one, or 2, or 3, or 4, and hit OK. And then it'll connect up to that network. There it goes. Sort of. It does it kind of twice. You watch the indicator up top. I think it's getting IP. There, it's done. So now I've just did 802.1x connection to wireless network. Anybody else connect? Yay! Let's give ourselves a round of applause. Yay! So now we're kind of left with the task of how do we can use these certificates, but you can see kind of the Herculean effort is trying to get the certificates onto the device, but once you do it, getting them, the Mac tends to use them relatively easy. We went to the website, we went to the 802.1x. There's actually no resources I put on this network. Just connecting, I figured, is enough. We can hand wave and say you can get access to resources now. So there's not actually anything interesting on that network. So I apologize I didn't have any more unicorns and rainbows. What's that?
That's a lot of work.
It is a lot of work.
I had to support 10,000 computers and generate for each of them.
Right. So we're going to talk about how to do this easier, right? You want to do mechanisms. And actually, getting the certificates is relatively easy. There's, as Josh mentioned, there's SCEP, there's a configuration profile, there's actually an Active Directory profile in the Profile Manager or for your MDM that you can generate those certificates. So once you have those, it's usually relatively easy to get it. If you do it manually, it's hard, right? But it illustrates kind of the process. So let me briefly go through SMIME because I believe in pain. Not because it's hard to set up, but conceptually it's difficult, right? So this is, how many people use SMIME to encrypt email messages, right? How many people love SMIME? All right, we got one person, okay. So this is, when you do this, it automatically, you don't configure in mail to use SMIME. It just shows up when you have a certificate or an identity that has an email associated with it that matches your email account. So you can see, I want to send a signed message. Who am I sending this message to? You don't know yet. So the question is, how can I sign it? Because what do I use to sign a message? My private key. Do I have a private key for me? Yes, I do. So I did that. So what happens when I want to encrypt it? I have to put, I couldn't encrypt a message until I did a recipient. Why is that? I need their public key, right? So that's why when you're typing in, I put somebody else, the encryption may disappear, which means I don't have the public key for that user. And I noticed this, I don't know when this came about, but I noticed that in Mail now you can select Show Contact and click the button, and it'll actually show the trust of that certificate, which is new. This little identifier, this big identifier, wow, that's kind of, this thing here, if you click on it, it'll show you the certificate, which is kind of neat. And if you look inside the messages, you can actually see that that's the encrypted blob. It's the same kind of information that we did before. And you can simply send a encrypted message as well and not sign it. We're running out of time on that. So let me just kind of finish before we do a couple of questions. The certificates are used in multiple other places. Secure Boot uses certificate to verify the signature. Actually, I have a session this afternoon on Windows on the Mac. It actually does Secure Boot in quotes because it's a different kind of Secure Boot than it does on the Mac or on Windows. It's its own version. But it does verify the kernel, or it verifies the bootloader on both Mac and in Windows, macOS and Windows. This is new for, I guess, the machines that just dropped today, the new MacBook Pros, as well as the iMac Pro. The Secure Enclave is the store for certificates that it trusts, sort of, because there's not a lot of documentation on the Secure Enclave and adding certificates to it. One of the things I did want to mention, because this is just a cool demo, is smart cards. So if you, like I said, a SIM card, if you're old school and work for the government, you may recognize these, right? It's a smart card reader. The cool kids these days use something like a YubiKey, right? And this can be a smart card as well. And so when I say this is a smart card, it means it has my certificate on it that's trusted by what I'm authenticating and my private key, all in this one little secure device. So look what happens when I plug it in. And this is it new in 10.13, Josh, or is it 10.12? 10.13, right? 10.13.4. For plugging in a smart card. Josh, pay attention here. Stop responding to email. If I plug in a smart card without doing anything, holy Moses, that's a lot of windows. It was 10.12? There, oh. There. So I just I randomly plugged in a smart card, right? My YubiKey. I haven't done anything, I didn't do any configuration. I get prompted with this dialog box, and it sees my 3 certificates on the smart card, right? So I could have generated a certificate instead of putting in the keychain, put it onto here. Either way. So I'll choose my one for authentication, and I'll say pair. I'll authenticate with my password, my fingerprint. Put my PIN in, please be right. Uh-oh. Oh. Keychain password, okay. There we go. And now when I log out, oh. Is this going to work? I won't be able to show it. I can show the login window, hopefully. Fingers crossed. There we go. No, I can't show the login window. But watch this. All right, never mind. Trust me. There it is. Now when I plug in my YubiKey device, it should change to be my PIN, and then I'll use certificate-based authentication to log in. And of course, the last demo I have doesn't work, so normally this does work. But one of the nice things is Apple's done a bunch of work on smart cards to be able to have it work in the login window. But it's one of the nice things is right out of the box, it sort of will use a smart card. Okay. And it does work for me. I'm not sure why it is. I blame the dongles. Always blame the dongles. All right. So we have 2 minutes for questions. Let's throw the box around for a few minutes. Any questions? Yes. Wait, hold on. Let me get the box because it's there and I want to use it. Yes.
So I do have an issue with iOS devices when you use that type of user certificate, because all of them show up with that same user certificate that you originally generate. So on your backend, your wireless backend, your iOS devices are showing with the same user, versus computers, they show up with their computer name because it's AD-based certificate, right? Is any way I can get around that?
So how are you using it to generate certificates? Are you using SCEP to do it?
I create a user in my Active Directory, and I just log in as that user, export that certificate, and then my Radius server, that's the user, it's allowed to authenticate to my secure network.
Right, so there's a bunch of ways to do it that if you understand the infrastructure, like hopefully what we covered, is that you could create machine accounts for each one of them and associate the certificate, and that would work. Or user accounts and do it. Or mass import it and to be able to do it. I've seen people use SCEP to where they'll do the MDMs will use SCEP to automatically issue a certificate, And the problem with what's kind of out of the box SCEP is it'll associate it with the same account, like you were just talking about. But you can actually move it in Active Directory or wherever your sort of repository is to the other accounts to associate with that. And I've heard people talk about, and I think some of the MDMs actually provide that functionality. But really, it's moving it to the correct place in Active Directory location or associate with the object that's going to be authenticating. And it can issue it, because you don't have the private key. It doesn't matter where the certificate is. It's not like it's going to hurt the client.
Thanks.
That's it. Thank you, everybody, for coming.